Hi, my name is Giovanbattista Mattiussi. I'm marketing manager for HPC in Eurotech. Eurotech is a global organization based in Italy, and we have two main business units. One is embedded computing and the other is HPC. We are present here at the SC13 in Denver with our HPC business unit, and we are presenting our products and solutions. The products you see at my back is called Aurora Tigon. It's a supercomputer that at the moment is occupying the first two positions of the Green 500. It's a very efficient supercomputing architecture. It's completely hot water liquid cooled, and this is one of the main characteristics of our systems, and one of the driver of the very high energy efficiency that we can reach. Also, the footprint is quite amazing because based only on CPU, this machine can store up to 6,144 computational cores, CPU cores, so the density is really high. Part another big announcement for this SC13 is actually a system which is called G-Station or Cube, depending whether it is hybrid mounting accelerator or is CPU only. The characteristic of this system, it is extremely small, absolutely silent. Basically under the table it can store up to 26 teraflops. Since it is water cooled, it's completely, absolutely silent. It doesn't need extensive, it doesn't need any infrastructure to be deployed, so it can even be deployed in an office. So the final result is that you can have a system which is substituting, replacing all your workstation, and is as silent as a workstation, but is tremendously more powerful. And actually, over there, you can see there is the cooling unit. So the computational unit is here, the cooling unit is there. The installation of this system is the same as for a split air conditioner. So that you can mount in your office, in your house, so it's quite simple. It's quite simple, but it's quite effective. Actually, we are here demoing the system together with an Italian software company called NICE and Altair Engineering. And we are demonstrating also the remote visualization capability of this system. It's mainly for industry, and especially in the fields of computer-aided engineering, rendering, I would say oil and gas. Those are, I think, the main application. We were also thinking about banking, but we are not still there. Okay. Now we are working very much with companies like Altair, ANSYS, or we render a company like Autodesk to actually characterize the system for industrial environments. I would say it can go from 60, 70,000 up to 150, 160. And above, depending on the processor, the kind of accelerator, the kind of interconnect, etc., you are using. It's in line with the prices which are now widespread in the market, with a premium for the fact that it's liquid cooled, silent, very compact, and that allows our customers to save space, to save energy, to not to resource to an extended infrastructure that is helping our customers to save money. But for us, of course, it's a value add that we compound in the final price. We probably would have not been able to reach such a high efficient results. So the GPU are playing an important role. Together with the Eurotech approach to the design, which is called energy aware design, and together with other components like being completely fanless and liquid cooled, maintaining then the temperature at the level, quite low level. So the CPU themselves, they can work better, they can work much more efficiently. It has been demonstrated that you can gain flops per watt by simply cooling the system with water, because that is increasing the efficiency of the components itself. But yes, GPUs, they were a fundamental contribution, and this result was also obtained thanks to the work we did together with NVIDIA. We have a very solid roadmap, a roadmap that we internalize, and also we do in collaboration with a lot of research centers in Europe, thanks also to the leverage we can do of European funds. And from that perspective, we are quite lucky to be in Europe. And so the roadmap, we will see some new systems coming in 2014. It's not that I can tell a lot about them, but it's going to be very interesting, innovative HPC architectures. One of our roadmaps, of course, is the traditional one. We follow NVIDIA internal roadmap, so we adopt the very new technology to run our machine faster and in a more efficient way. At the same time, we are working in a research and development project to actually develop innovative architecture. We are pushing that further to get as close as possible to exascale, consuming as little as possible. We are designing, for instance, a new cooling system which is based always on the concept of cold plate, while we are trying to make it more efficient and even cheaper. At the same time, we are playing with the architecture. It's common, it's public, so I can tell what we do, for instance, in the DEEP project, Dynamic Exascale Entry project, where we are testing the concept of cluster of accelerators. We have the knowledge and the know-how and the facilities to actually implement then the systems.